All right, it's time to do our next video. Our next video, doing some practice on confidence intervals, and it will feature probably this little troublemaker. Say hi, October. Look at her. Doesn't she look like she's ready to pounce? All right. So we had a poll, and this poll asked 166 adults in the US whether they were baseball fans. And 46% said that they were. Right? That immediately tells us that the sample proportion was 46%. We don't know the true proportion. This is an estimate. We're estimating it with a point. It's a point estimate. P hat, 46%. That's our estimate. But let's get an interval estimate. We'll interval estimate with a confidence interval. Okay? So construct a 99% confidence interval for the true proportion of US adults that are baseball fans and interpret this. So let's say we forget, hypothetically, we scroll up and figure out how to find a confidence interval. It's p hat plus or minus z star, the critical z-score, times the standard error. Right? All this is sampling distributions. What is the middle 99% of sampling for this sampling distribution? All right, so we're going to copy that down. Confidence interval is going to be p hat plus or minus z star times the standard error, which will approximate with this formula. It looks like a little sad face. Any artists in this class, you'll make me very happy. Look, it's like a head. You see it, right? With the hats are like the eyebrows, and the P and the Q are like tears. N is like the mouth. I need a rendition of this. Okay, the sad standard error. Okay, so construct blah blah blah. This is how we find it. So we know some of this, right? P hat is 0.46 plus or minus z star. Z star is the z value. Remember, z value means, I want to make sure I'm consistent. Do we have the asterisk as a superscript? Great. I was making sure that the asterisk goes on top of the z and not on the bottom, depending on our notation. So z star is just how many standard deviations are we away from the mean to get 99% of the data. And we found out in the video above that for 99% of the data, we're 2.576 standard deviations away from the mean. If we're within 2.576 standard deviations of the mean, that's where 99% of the data is. So there's a 99% chance that the true proportion will be in that interval. Okay? And then multiply that by the standard error. Again, as a reminder, this is like the mean of our sampling distribution. This is the z value. You know, it's the critical z-score is what we're calling it, but it's basically the z value for how many standard deviations away from the mean we have to be. Critical z-score. And this whole thing is what's known as the standard error. The standard deviation of the sampling distribution. All this formula is sampling distributions. This is why it's connected to the last unit. So times the square root of p hat, which is 0.46, times q hat, which is 0.54. Remember, q is just 1 minus p, divided by our sample size, 166. Well, that's 46% plus or minus. Let's use a calculator. Let's approximate this margin of error. That's another definition, another term right here. This whole thing here, that's known as the margin of error. right? And that's another way that confidence intervals are oftentimes described, right? Get to that when we get our answers. Let's approximate this with a calculator. 2.576. Oops, wrong page. Oops, the average, what was the average? 0.46. Oh, no. 2.576, that's what we want. Times the square root, 0.46, times 0.54, divided by 166. What is our margin of error? About 0.09965. You could approximate it. You don't have to have this many decimal places. You could approximate here. I think it would make sense to go to 2 decimal places because that's what we have for P. But I was just copying down a bunch. This is our confidence interval. Confidence interval, sometimes abbreviated CI. Or you could write this in interval notation, right? This is about the interval 0.46 minus 0.1, 0.46 plus 0.1 is about this interval. 2 ways of expressing your answer. Thing on the above and the thing on the bottom. So we're 99% sure, based on this sample, we're 99% sure that the actual percentage of adults that are baseball fans is somewhere between 45 and 47%. Let's write that down. We are 99% confident that the true proportion of US adults that are baseball fans, the true proportion is between 45% and 47%. That's our explanation here, which seems really high to me. I don't like baseball. I find baseball so boring to watch. Like maybe to play it, well, even to play it, I feel like there's a lot of sitting around. And I don't know. Sorry. I'm in the 50 something percent, right? 45 to 47%, 99% confidence. 45 and 47% is somewhere where between which that's the actual percentage of baseball fans in the US. Well, I'm in the other half. All right, construct an 80% confidence interval. So it's almost the same, right? It's the same formula. Whoa. The same formula for confidence intervals. Same p hat. That's our mean in the sampling distribution. Same standard error. But the z-score, that critical z-score, is going to be different. So it's still 0.46 plus or minus something times the square root of all this. The only difference is that critical z-score for 80% confidence level. So you can go to a standard normal probability distribution. And you could find what are the z values? How do we find the middle 80% of data? Those z values give you your z star. Or we can reuse the information they got earlier. For 80%, that's 10% on each side. Our z star is 1.282. All right. We can again evaluate this with a calculator. So it's still centered at the same thing, right? It's still centered at 0.46. But now 2.282, was that it? I don't even remember. 1.282. 80% of the data is around 1.3 standard deviations of the way from the mean. That's about 0.05. So here, let's actually add this to our answer. If you remember here, our margin of error is 1%. Right? We're estimating that it's 46%, a 1% margin of error. Another way of adding more information. A lot of times we'll write margin of error, mo. And so here's very, very similar, right? We can be 80% confident. Well, what is this interval? Wait. I did something wrong, didn't I? 0.05%. Yeah, I did something wrong. Back here, when I did my math in my head, over here, I hope you've been screaming, by the way. This is about 0.1, not 0.01. Is that confidence interval? Right, it's adding 10% on each side. So maybe it's as low as 36%. Maybe it's as high as 57%. Right, 0.1 or 10%. Whew. So we're 99% confident that the true proportion of US adults that are baseball fans are between 36% and 56%. Goodness, I'm out of control. This is a downside to videos. In person, if I did something like this, y'all would be like, Jason, hold up. You're messing up. Here we go. This should be correct. 36 and 56%. Our margin of error is about 10%. We're estimating it's 46% with a 10% margin of error. So margin of error is huge here, right? It's because our sample size is so small. We're only asking 166%. So if you're asking me for an estimate that I'm 99% confident about, that's a tall order. I only had asked 166 people. I can't be 99% confident about something very easily. So I have to estimate with a really big interval. In order to be 99% confident that it's in that interval, I need a big interval, right? It's like you're throwing darts at a dartboard and they're making a bet and say, pick the region, draw the circle, Jason. Draw the circle on the wall, throw away the dartboard. We're throwing it in the wall now. Draw the circle on the wall that you can be 99% certain that you're going to hit with that dart. Well, I'm going to need a big circle to be 99% sure I'm going to hit it. I suck at darts. Small sample size, 166. We suck at asking questions, this poll, right? It's a really big interval here for a 99% confidence level. Whereas over here, notice that this confidence, this margin of error is 5%. So here it's down to 41% and up to 51%. Or likewise, let's say what it means over here. We are 80% confident that the true proportion of US adults that are baseball fans is between 41% and 51%. Our margin of error is 5%. We're estimating still, right? We have the same p hat. We have the same point estimate that the true proportion is about 46%, a 5% margin of error. Now notice this interval is smaller, right? 99% certain it's in this interval. Only 80% certain it's in a smaller interval. So if you said draw a circle, Jason, I'm actually staring at my wall. You can't see it, but that's why I'm turning it this side. Draw a circle, Jason, that you'll be 80% sure. Well, if I don't have to hit as many darts, I only have to hit 80% of the darts, I can draw a smaller circle. So it kind of works backwards from what you might think. Smaller circle means that we're less confident it's in there, because we're going to be accurate less of the time if we have a smaller target. So bigger target means we're going to be more confident. Smaller target means we're going to be less confident. That's the corresponding how confidence intervals change with confidence levels. So last thing in this video, I think, certainty versus precision. That has to do with the precision of me throwing those darts. Every p hat is like a dart I'm throwing. What happens to the size of the confidence interval, the more certain you are. So the higher the confidence level, if I want to be really sure that we're hitting that dartboard, I'm going to have a big interval. Okay. So the interval has to be bigger for us to be more confident that we're inside of it. Right? Think of the darts. Has to have a big interval, has to have a big circle if we're supposed to be confident that we can hit it. And then similarly, right? If we're less certain that it's in the interval, we can afford to make the target smaller. Right? Smaller target, smaller confidence interval. If we don't have to be as sure, we can have a smaller target. Right? It's like if you're working. Well, let's not draw that analogy. Let's be done with the video. Let me know if you have questions. To actually calculate these is pretty straightforward. It's just using a formula up here. But to understand, that's the true gem right here. And it's going to be really useful in the next unit as well with hypothesis testing. So even if you just feel like, yeah, I can do this, but I don't really know what I'm doing, that's a perfect thing to ask about. Okay? I'd love to talk about it. This is cool stuff. It's very useful stuff in a lot of different applications. We see confidence intervals everywhere, right? If we're looking at any kind of sample, any kind of poll, a lot of times it'll say like, this politician or this measure has like a 60% approval rate, plus or minus 2 percentage points. Those 2 percentage points are our margin of error. Add that 2 percentage points, subtract that 2 percentage points, that's a confidence interval. And a lot of times they'll tell you how confident they are as well in those reports. That's what they're talking about, all right? So this gets used all the time, and now you know what it means and where it comes from, at least a little bit. And we'll talk more about it as well.